man-in-the-middle proxy.
So yeah, that's the original title of the talk here, is embedding web apps in man-in-the-middle proxy. That's actually not the talk you're going to get delivered today, but I'll go into that in a minute. So why did I start trying to embed web apps into man-in-the-middle proxy, or MITMProxy as I call it, because it's easier to say, so that's what I'm going to say for the rest of this talk. I was curious about this mobile game called Ruzzle that my girlfriend told me to play. It's just like a word game, kind of like Scrabble or Words with Friends. And I was looking at the HTTP traffic, and it was all encrypted, and I was like, oh, what the hell? Can't really figure it out. As you can see here in the lower left, it's just gobbledygook, but the content type is JSON. Interesting. So I wanted to look at that and be able to examine that from MITMProxy. So I started off by embedding WSGApps written in Python into MITMProxy scripts. And as I was doing this, I created this like crazy UI here, and you can see here this is running in the web browser, and like you can click and view requests and responses, and you actually see the JSON here. So I'm decrypting it, that encrypted traffic. You can view it, and then it has like a checkbox to enable the cheat, and it kind of worked, but there were some drawbacks to that, particularly in terms of concurrency and stuff, because everything was single-threaded. So basically, web requests would block MITMProxy itself. So this really wound up being unnecessary. Since February, when I started working on this, the MITMProxy developers have added a new web front end to MITMProxy. It's really nice. And it turns out I was just using the wrong mechanisms to do this work. While you can embed WSGApps into MITMProxy, it's an undocumented feature in there. The developers don't mention anywhere. I just found it by looking through their source code. You can't yet threads safely interact with the MITMProxy flows, and it turns out that it's very non-trivial to introduce thread safety into the netlib library that MITMProxy uses. So the use cases for the embedded WSGApps are more for things like hosting static assets that you want to deliver to people who are running through your proxy, or running a web server accessible to machines going through the proxy. And for my case, where I wanted to just expose some additional functionality based on the application that I was working with, it wound up being easier to hook into the master MITMProxy state directly. So you're no longer going to see this talk. Instead, the talk that you're going to see is what My Little Pony, Friendship is Magic, can teach us about threat intelligence, sponsored by ThreatBud. Just kidding. I'm actually going to talk about plugin support in MITMProxy Web, which is what I've added. Or why nobody wants to play mobile games with me anymore. So what is MITMProxy, for those who don't know? MITMProxy is a Python-based library for HTTP and HTTPS interception. Can automatically create an SSL cert and do SSL interception. I mean, you have to install the cert and bypass pinning in your client app and stuff, but hand wave. And the developers have a few front ends for it now. There's the web UI, which what my work primarily focuses on. However, it can be brought into the ncurses GUI. I plan on doing that. Then there's the MITMProxy front end itself, which is all ncurses-based console stuff, which is where I originally started my work. And then there's MITMDump, which runs completely headless, and you can just create the HTTP equivalent of PCAP, basically, for MITMProxy. So it's had this scripting interface for a while, which you can invoke through any of the front ends by passing a -s argument on the command line, and then the name of the Python script that you're using. This was not actually supported on the MITMWeb UI when I started doing this work, so I brought the support in, got it all working. So scripts wouldn't even run in the background, much less have fancy buttons in a web UI for you to click. So I've introduced a couple of new concepts into MITMProxy. The three concepts are view plugins, action plugins, and plugin options. I'm going to go into those more in depth. So a view plugin, this changes the visual presentation of traffic going across the wire without actually changing what's being sent to the server or client. So this is useful if you just want to transform it in the interface to view a different representation of it. For example, right here, I'm showing off a hex view. So you'll see at the bottom, it says auto hex, and then there's a new hex tab. MITMProxy's web UI didn't have hex support when I started this work. So I created a little hex dump plugin, Add it. Now you can view hex in the browser. It's super easy. I also added plugin options. These are persistent options that you can configure. You have different types that you can create. And those just configure the plugin behavior, and they persist across every flow that the plugin runs across. So for example, here we have a color switcher plugin, and we have a configurable color in the interface. I added plugin output. Plugin output is just static text that you can have your script print to the plugin options page to display debug or stateful information about what the plugin's doing. So for example, right here, this is for my Ruzzle cheat plugin, and this is just showing the games as detected that are in progress and a little bit of information about them. Then I also had plugin actions, and these are available on either a one-off basis or to run persistently against every flow. So right here, this is my color switcher and pig/pug Latin plugin. So the color switcher, like we saw before, you can configure a color you want to switch to. So previously, Vice wasn't so pink. And then also the pig and pug Latin, well, it changes text to pig Latin and changes every image to pugs, and it makes Vice a hell of a lot more bearable. So then on the plugin options page, you can also configure any plugin actions that you create to run across every flow, so you don't have to manually click on the flow and click run action again. So you can say run in every flow, and it'll go. But back to cheating at mobile games. So it turns out that reversing many Android apps isn't really hard, especially crappy games. You can usually get pretty good Java code out of it after you open up that APK index to jar and poke around. So finding the AES shared secret was super easy. And then the crypto IV wound up being in the request headers themselves. Wrote like a basic little routine to decrypt it, tested against some traffic. It worked. Cool. I noticed some other things that I thought were interesting that I just want to bring up while I was reversing the game, because they were just bad ideas. For example, the game had a rudimentary anti-cheat functionality built into it. And so it turns out that this game's really popular. There are like over 10 million installs according to the Google Play Store. And people have made cheats for it that you can download on the Google Play Store. So the game itself will check to see if any of those processes are running and then report your score as a 0. However, this is all enabled on the client, and it won't help against a network attack like what I'm going to show here. And then they also had partial request signing, so the headers had a signature in them, but it only extended to parameters that were actually within the headers. It didn't take into account any of the request body. So for my work at cheating at the game, I didn't even have to re-sign anything. And then also the client reports your game score and everything, and the server will just accept it. It doesn't even bother verifying if the score makes sense. You could say, I didn't even play any words, but I got 1,000,000 points, and it's totally fine with it. So after I wrote my little routine, I was able to decrypt the traffic, which you can see on the left there. And then I used my new Vue plugin support to create a Vue plugin. So now we actually get JSON on the front end. Sweet. And as far as cheating goes, so when I first started this, I was like, oh man, we have to like look at the board and figure out every possible combination of moves you can make, and then compare it against a dictionary and find words and stuff. But wound up not being necessary at all. So it turns out they give you every possible word that you can play in the game requests themselves. So yeah, I just kind of concatenated all these and it worked. So they have a move string format that they have in there. It's a little bit more Java reversing, and it was easy to write a Python implementation of it. And then suddenly I was really good at the game. You can see my score jumped an order of magnitude. There was some data sent along that could possibly indicate cheating to the service provider. So I was like, it'd be fun to kind of fake that, fudge that around, and try and evade any possible detections. So some of those things that they sent along that could indicate cheating, if you don't take them into account, they record the swipe distance, which is the distance that your finger actually travels on the screen. They also record the time that you play each word. So I just kind of fuzzed those. I played a couple of legitimate games, and took averages and then add a little fudge factor into it, and seems to be okay. So like I said, wrote some routines to fake all that and wrote a plugin action for it. So basically it'll take that encrypted blob, decrypt it with the AES key and IV from the request, change the state to basically say that you got a bunch of points and you played a bunch of words and you're really good, re-encrypt it and send it along to the server and you get a bunch of points. And then I brought in the plugin. So what I did with the plugin, I created a few different things here for this game. I did 2 plugin actions. One to identify the games. This is because you can either be player 1 or player 2, and the only way to determine if you're player 1 or player 2 is from read game request. And then one to actually perform the cheating, which is against the play round requests, which say which words you played. I had a plugin output option just to show the in-progress games that the script had detected and that it would be cheating against. And then, of course, I implemented that view plugin that would show the decrypted traffic on the front end without actually affecting on the wire. Of course, all this work goes beyond games. Kind of use your imagination here. There are a lot of possibilities. In any circumstance where you want to do any sort of dynamic content replacement or data extraction or exfiltration or have use case specific data views, could come in handy. So here's some example plugins I kind of thought about, like do like a password thief and steal passwords from forum posts, or something that embarrass people posting on forums and replace all their posts with some crazy bullshit, or a last measure plugin and inject JavaScript to open last measure on every site that they load and open up Goatse and Lemon Party and stuff. I also thought you could do like useful things with it too. Like maybe a web app fuzzer, kind of like some of the features that Burp has, where you could look at request parameters that are taken in and then do some fuzzing with them and then replay all the requests against the server and see how the server responses change and record that. You could also do like a malware injector. Then I had an idea earlier, like you could even like, if you saw someone uploading images to Imgur, you could like do some stego stuff and hide data in there to exfiltrate. There are a lot of possibilities here. So the actual process of writing plugins, I'm going to talk about a bit now, so that you guys can start writing your own. So there are 2 concepts in MITMProxy that are affected by this, context and flows. So a flow is basically an abstraction of an HTTP request response flow. It has a few different attributes. The request, which contains contents and headers, etc. The response, which isn't necessarily there unless the flow has actually gone out to the target server and returned, which also has, of course, contents and headers, etc. Error, which is about like HTTP errors that may have occurred. And then you can also get a reference to the TCP connection to either the server or client itself. Then the context contains a handful of useful utility methods that come in handy when writing scripts. So it's known as a script context. And the script context has a log method, which you can use to log out to the terminal. You can kill a flow as it's happening so that it won't reach the server or won't reach the client. You can duplicate it. You can replay them. So basically you can take these flows, duplicate them, manipulate them, resend them, kill them, do all kinds of stuff with the script context. So I'm going to go through a couple sample plugins here and show how they're implemented, show how simple it is to start doing this and like how easy it is to get these things to appear in the UI now. So common to all MITMProxy scripts, they have a start method available. This takes in a context and some arguments, which are taken from the command line. So basically right here, we start off by defining our transformation method for this view plugin, which is our hex view. Every transformation for a view plugin will get a keyword argument called target, which specifies whether it's currently running on a request or response. So do a little bit of checking here to see what the target is, and then grab the appropriate attribute of the flow, and then grab the content. So then the next responsibility of the transformation method is to perform the transformation and then return it as a string. So the last line of hex dump is just return the hex string that we've created. And then at the bottom, we call context.plugins.register view. The first thing we pass is an ID for the plugin, and then you can pass a title for it, and then you specify what your transformation function is. That's it, and then you have that hex thing that you can click on. You can do a hex view, and really easy. For an action plugin, which is one that will actually change the contents of what's going across the wire. Once again, we use that start method again to register it, but this time we're going to call register action as opposed to register view. You can register multiple actions at one time for a plugin. So right here we only register one. And it's important to note that the ID attribute in here is actually the transformation function. So you specify ID as puglify image, which is our method at the top level of the module or the script. And then you can also specify possible hooks. So you can say that this transformation can only run on requests, or this transformation can run on requests and responses, or only responses. So for right here, our puglify plugin, it really only makes sense to run it across responses. So we specify that. And then you can also specify a beginning state for the action. In this case, we're specifying every flow as true, which means that it'll come pre-configured to run against any flow that passes through it as soon as you start up MITMProxy. And then our actual transformation function is pretty straightforward. Basically, we just check the content type, see if it looks imagey. And then also, because web developers are terrible, they don't always use content types. So we also just check for a JPEG magic string. I mean, you could make it way more robust. I just do this as a proof of concept. Then, grab our pug image and replace the contents with it, and call it a day. So for a more complex example that uses options, I have one here, our color switcher. So this one will replace instances of hex color codes in either CSS or HTML files with a color that you can configure in the UI. So we set to a nice pink here, and we turn vice pink. The action step, again, should be familiar. But we create another action here called disable cache. This one will just add some cache control headers and stuff to the request to turn off client-side caching. That way we can ensure that we get a fresh CSS file that we can change colors on. We also specify our options keyword argument here. And in that, we specify that we have one text option called color, and we specify a default value for it. You can specify different types. They can, be drop-downs or text or checkboxes, etc. And you can also take a default value. So our two transformation functions are right here, disable cache and colorify. Disable cache runs only on the request, of course, adds that no cache, and changes the if modified since header if it's present. Our color function right here basically just looks at the content type, sees if it's CSS or HTML. If it is, just runs a cheesy little regular expression on it to replace the color. Now the important part here to note is how to actually get that option value. So we call context.plugins.getOptionValue. We specify the name of our plugin, then the name of the option whose value we want to retrieve. In this case, it's the color switcher plugin and the color option. So now what? I've been working closely with the MITMProxy developers, and a pull request is in with like 8,000 changes here. There are a few improvements I'd like to make to this, but it works for the most part. You can go and grab my branch and play around with it if you want. The developers are also really, really cool people and really open to pull requests and really helpful if you hop into their Slack. They'll tell you anything about the code base you want to know. So I want to make some improvements to it, like I said, basically code style, make it match the rest of the code base that they have there. Also finish out the unit test I started writing for it. Add more option types for the UI. Maybe add some kind of composition or ordering for plugin action execution, though I think that's really not even necessary. And then just UI enhancements. The CSS is a little wonky still. So how can everyone here start using web plugins now? Well, it's not integrated to the master branch yet, so here's a discussion I had with Max, one of the developers, yesterday. He said he's looking at it today, so maybe it'll be up today. I don't know. But for now, you can grab my branch in GitHub. So here's some resources for everyone. I have all my example scripts here. You can grab on GitHub. You can also grab my MITMProxy branch with the web plugin support. And the main MITMProxy site is here, and they have tons of documentation and examples and stuff. It's really great. They put a lot of effort into it. So I would like to say thank you to the MITMProxy developers for all their hard work in making this awesome tool, and for all their work in answering all my noob questions about their code base, like, how is this supposed to work? So, thanks, guys. And then, if anyone has any questions, you can just kind of grab me or hit me up, email or Twitter or whatever. That's all I have for you.